All right, to summarize everything we've kind of discussed, we looked at some of the functions, the trig functions, the sine function, the cosine function, the tangent function. We also looked at their trigonometric functions, which include the cosecant function, the secant function, and the cotangent function. And we also we looked at those ratios, and we also discussed this notion of special angles, which included the 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 180, 270, and 360 degrees. And we discussed how these special angles, the exact values of the ratios, could be determined by using the special triangles, the unicircle. I'm just going to summarize all of this out for you guys. Right, so let's start with, these are just values of theta here. Right, so this is theta. And let's start with sine theta, cosine theta, tan theta, and then we'll also look at the reciprocal values, right? I would just recommend memorizing sine, cosine, tan, but I'm just going to put all of this out there for you guys, just in case you wanted to memorize the rest. I don't think it's useful, but it's better to memorize sine, cosine, tan, your primary trig ratios, and then for your reciprocal, you just have to take the reciprocal of their ratio values. You just flip the numerator and denominator. But I'm just going to put all of this out there for you because it does bring up a very important point that we will later on discuss when we study these, the behavior of their trig functions, of these trig functions graphically, right? So we looked at sine, cosine, tan. We'll also look at cosecant theta, which is the reciprocal of sine, right? Cosecant theta is 1 over sine theta, right? Secant theta is 1 over cosine theta, and we'll also look at cotangent theta, which is 1 over tan theta. Okay, so keep this in mind, guys. So I'll write secant theta here and cotangent theta here. Okay, I'm going to start with cosine and sine really quickly first. So for the unicircle, we had sine theta, sine of 0 is basically 0, cosine of 0 is 1. We also looked at, I think I briefly discussed the quotient identity, that tan theta, and I showed you guys this through the proof of the unit circle, that tan theta is equal to sine theta over cosine theta. So having said this, although we had values from the special triangles, which included 30 degrees, 45 degrees, and 60 degrees, where we actually determined tan theta, for the unit circle, you can actually just divide sine over cosine to find tan. So when you do tan of 0, for instance, right? So tan 0, let's just do it here. So tan 0 here is equal to sine 0 divided by cosine 0. Okay, so tan 0 is sine 0 divided by cosine 0. In that case, sine 0 here is 0, cosine 0 is 1, so tan 0 is 0 degrees. And that's how you would basically solve for it. Sine 30 degrees, we said was 1/2. Cosine 30 was square root 3 over 2, right? And as a result, tan 30, you could divide these two, right? And you can prove that here if you wanted to. So tan 30 degrees should be equal to sine 30 divided by cosine 30, which is basically equal to 1/2 divided by square root 3 over 2. If we simplify that, 1/2 times 2 over square root 3, so you actually get 1 over square root 3, which we simplified as square root 3 over 3, right? And we know this is true because by drawing the special triangle, this was square root 3 over 3, okay? Sine 45 was square root 2 over 2. Sine 60 was square root 3 over 2, which is the same value as cosine 30, and we looked at that notion that sine theta is equal to cosine 90 degrees minus theta, right, and vice versa, that cosine theta is equal to sine 90 degrees minus theta as well. Okay, so this is another thing that we investigated. So cosine 45, same value as sine 45 square root 2 over 2. Cosine 60 is the same value as sine 30, which is 1/2. Sine 90 was 1, cosine 90 was 0, right? And tan 90 as a result is 1 divided by 0, which doesn't exist. Okay, so 1 divided by, and whenever you have 0 on the denominator, it doesn't exist. Tan 45 was 1, tan 60 was square root 3 over 1, right? Sine 180 from the unit circle we determined was 0. Cosine 180 we determined was -1, and then 0 divided by -1 is 0. Right, sine 270 was -1, cosine 270 was 0, tan 270 is sine 270 -1 divided by cosine 270, which is 0, doesn't exist, right? Sine 360 was 0, cosine 360 is 1, and tan 360 is 0, okay? So those are the values for our primary trig functions, right? These are your primary trig ratios. Let's take a look at the reciprocal values, right? Cosecant 0 degrees is basically the reciprocal of sine. Now this is basically, for sine theta, this was 0 over 1, right? So it was basically 0. So cosecant is 1 over 0, which is undefined, right? Because this is 0 over 1. If you do the reciprocal, it should be 1 over 0. So this is undefined, does not exist, right? Secant, however, it's the reciprocal of cosine, right? So pretend that this is 1 over 1, so secant, you just flip it, so you'll get the same value, it's 1. Okay, guys? Right? Cotangent doesn't exist, right? So cotangent theta is basically, if tan theta is sine over cosine theta, then cotangent is cosine theta over sine theta, and sine theta doesn't exist, right? Well, sine theta is 0, right? So it's 0, 1, it also doesn't exist. Okay, so keep that in mind. Cosecant 30 is basically the reciprocal of sine 30, so it should be 2 over 1, right? Secant 30 is 2 over square root 3, and you guys can simplify this, right? You can write this, if you multiply by square root 3, right, you get square root 3 over 3. Okay, so I'm sure you guys know how to do the radical simplification, right? So it's 2 square root 3 over 3. And then cotangent theta is the reciprocal of sine, so you get 3 over square root 3. And if you multiply this guy out, right, you get 3 square root 3 over 3, which is basically square root 3. Okay, so square root 3. Cosecant 45 here is the reciprocal of sine, so it's going to be 2 over square root 2, which is square root 2 over 1. Okay, and same idea with secant. And then cotangent here is still 1. Okay. For cosecant 60 degrees, that's going to be the reciprocal of sine. So it's going to be 2 over square root 3, which we stated was 2 square root 3 over 3. Okay. The reciprocal of cosine 60 is 2 over 1. And then this guy here is going to be 1 over square root 3, which is basically square root 3 over 3. Okay, guys? Okay, so then we also have cosecant 90, which is 1, it's reciprocal. Secant 90, on the other hand, we know that cosine 90 is 0, so it's 1 over 0, so it doesn't exist. Okay, and cotangent also doesn't exist, right? Because you can see that it's sine is cosine 90. Oh, sorry guys. Wait, so cotangent 90 is equal to cosine 90 over sine 90, right? And that's going to give us 0 over 1. So this actually does exist. So cotangent would actually be 0 here, right? So there, the restriction is gone now, right? So keep that in mind, right? So in this case, cosine 90 is 0, sine 90 is 1, so that's why it will exist. And then we can figure out the rest. So cosecant doesn't exist because it's 1 over 0. Secant here will be -1, and then cotangent would be, let's do it out here. So cotangent cotangent 180, just erase this out. Cotangent 180 is equal to cosine 180 over sine 180, and once again this is undefined as well, right? So this doesn't exist either. Okay, cosecant 270 is still -1. Secant 270 doesn't exist because you get 1 over 0. Cotangent 270, let's write that out. 270 is basically equal to cosine 270 over sine 270 when this is going to give us 0. Okay? We're 360 here. This doesn't exist because you get 1 over 0. This is 0 over 1. You flip it. Secant, you get 1. Right? And then cotangent 360 is going to be the same as 0 degrees, as also doesn't exist. Good? And this is your full out chart, guys. Okay, so it did take us a while, but for the most part, I would recommend kind of knowing these out. Once you know these out and you know the quotient rule, you can actually figure out the rest. And you know that reciprocals, you just flip the numerator and denominator, right? So, but I decided to do the full chart for you guys so you guys can have a good summary of all of this. All right, so that's the idea of special angles. So I would really recommend you to memorize this set that I've highlighted in yellow.